When scientists point the James Webb Space Telescope deep into space, they're really pointing it back in time. The farther away we look, the older the light we see. With Webb's incredible sensitivity, astronomers are now peering into the first few 100 million years after the Big Bang, the era when the very first stars and galaxies should have formed. At first, researchers expected to see faint, tiny smudges. The earliest galaxies were thought to be small, fragile, and just beginning to gather their stars. Instead, Webb returned something entirely unexpected: bright, massive, and surprisingly well-developed objects glowing in the ancient universe. One galaxy, known as Jade's GSZ-14, appears just 290 million years after the Big Bang. That's like opening a baby album and finding a picture of a fully grown adult. It shouldn't exist, at least not according to our current theories. And this isn't an isolated case. Webb has uncovered dozens of candidates, some so massive they seem to contain as many stars as the Milky Way, but forming when the universe was still in its infancy. Here's the problem. Our standard cosmological model, the lambda cold dark matter model, predicts how matter should clump together after the Big Bang. Galaxies, in this picture, form slowly as gas cools, dark matter pulls structures together, and stars ignite over billions of years. But the galaxies Webb is showing us look like they skipped that slow build-up. They're already huge, dense, and shining brilliantly in the cosmic dawn. Some galaxies appear to have turned nearly all of their gas into stars, reaching a level of efficiency our physics says is impossible. Normally, only about 10% of a galaxy's gas makes it into stars. The rest lingers as raw material, fueling star birth over time. But these early systems seem to have burned through everything almost instantly. How could that happen? To make sense of this, we need to zoom out. For nearly a century, we've known the universe is expanding. Galaxies move away from each other as space itself stretches. And not only is space expanding, it's accelerating, driven by a mysterious force we call dark energy. This expansion gives us a horizon, known as the observable universe. It's about 92 billion light-years across, and it defines the limit of what we can ever see. But Webb is showing us that within this horizon, the story of cosmic history may not be what we thought. A recent study found nearly 90 galaxies existing just 200 to 400 million years after the Big Bang. If even a fraction of these are confirmed, we'll need to rethink the entire timeline of galaxy formation. Some scientists suggest that maybe these objects aren't galaxies at all. They could be something new, structures unlike anything we've imagined, formed by unknown physics. Others have gone further, proposing that perhaps the universe didn't begin in the way we think. What if the Big Bang wasn't the true beginning, but just one chapter in a much older cosmic story? The implications are enormous. If our theories of galaxy formation are incomplete, it means the role of dark matter, star birth, and cosmic evolution might all need to be rewritten. If our timeline of the early universe is wrong, it could point to deeper truths about space, time, and the very origin of everything. And yet, amid this uncertainty, one thing is clear. The James Webb Space Telescope is already reshaping our view of the cosmos. With every image, it's challenging long-held assumptions and reminding us that the universe is far stranger, far more dynamic, and far more mysterious than we dared to believe. So what are these strange objects really? Are they the very first galaxies, racing ahead of schedule? Are they an entirely new kind of structure, built by physics we don't yet understand? Or are they hints that our picture of the Big Bang itself is incomplete? For now, we can only wonder. But as Webb continues to push the boundaries of sight and time, it's opening a window into the unknown. A reminder that the greatest discoveries often begin with the things we cannot yet explain. Imagine standing at the edge of a vast ocean, knowing there are islands beyond the horizon that you've never seen. That's exactly what astronomers are experiencing now. The James Webb Space Telescope is like a cosmic lighthouse, revealing islands of light in the ocean of time. Objects that challenge everything we thought we knew about the early universe. Each new discovery is a mystery, a question mark painted against the darkness of space, daring us to explore further. One of the most astonishing aspects of these findings is how quickly these ancient structures seem to have formed. Galaxies with billions of stars, forming when the universe was only a few 100 million years old, an era we once thought too young, too raw, too chaotic to allow such complexity. These early cosmic giants are not just anomalies, they are clues. They are evidence that the universe had the ability to create, organize, and shine in ways our models never predicted. And it's not just the galaxies themselves that are puzzling. Their behavior challenges fundamental physics. How did gravity pull together enough matter so quickly? How did stars ignite with such efficiency? How did these structures survive the turbulent conditions of the early universe? Each answer we uncover seems to raise even more questions, pushing the limits of human imagination and scientific understanding. Some researchers are beginning to wonder if we've been looking at the universe through the wrong lens all along. Perhaps the so-called early universe is more complex than a simple timeline from the Big Bang to today. Perhaps there were processes, forces, or even phenomena that we have yet to imagine, mechanisms that allowed matter to assemble faster, shine brighter, and evolve more rapidly than we thought possible. This is why Webb's discoveries are so exciting. They don't just add pieces to a puzzle. They force us to reconsider the shape of the puzzle itself. Cosmology, once a field of predictable timelines and elegant equations, is suddenly alive with mystery. The universe is no longer a story we can fully anticipate. It is a narrative still being written, with chapters that surprise even the most seasoned scientists. And in a way, that's the beauty of it. Science thrives on the unknown. Every strange, inexplicable galaxy is an invitation to ask bigger questions. What truly governs the formation of matter? How does the universe organize itself on its largest scales? Could there be structures, laws, or events in the cosmos that we have never observed, because our instruments weren't powerful enough, until now? As we peer deeper and further with Webb, we are reminded of our place in the cosmos. We are witnesses to the birth of stars, the growth of galaxies, and perhaps even the first moments of cosmic organization. Each photon captured by the telescope has traveled billions of years to reach us, carrying secrets of a universe that is both unimaginably vast and surprisingly close, in the sense that it connects us directly to the story of existence itself. The next few years promise more revelations. As Webb surveys more regions of space, as it captures fainter objects and records their light in unprecedented detail, we may finally begin to understand what these early cosmic giants are, and perhaps even revise our conception of how the universe came to be. We may find that the early universe was more dynamic, more complex, and more wondrous than we ever imagined. And perhaps, in that process, we will realize something even more profound. The universe is not a static backdrop for our existence. It is a living, evolving entity, full of surprises, full of structures beyond our current comprehension, and full of stories that are only beginning to reveal themselves. In the end, Webb is teaching us humility and curiosity in equal measure. It reminds us that for every answer we discover, there are 10 more questions waiting. It shows us that exploration is not just about reaching a destination. It is about the journey itself, the act of looking, questioning, and daring to see what no one has seen before. So as we continue to explore, as the telescope captures more light from the edge of time, one truth becomes clear. The universe is stranger, more beautiful, and more mysterious than we ever imagined. And the story of its origins, and perhaps even its destiny, may still be waiting to astonish us, just beyond the next horizon.